There is one decision you make every time you change your oil that determines whether your engine reaches 100,000 miles or 500,000 miles. It is not the brand you choose. It is not whether you use synthetic or conventional. It is not the additives printed on the bottle or the marketing claims about protection and performance. It is a single number printed on every container of motor oil sold in the world, a number that most owners never think about and that most mechanics select automatically without considering your specific engine, your specific driving conditions, or the specific wear patterns developing inside your motor right now. Japanese mechanics obsess over this number. They calculate it based on engine age, operating temperature, driving patterns, and accumulated wear. They change their recommendation as vehicles age. They understand that the same engine at 20,000 miles and 200,000 miles requires fundamentally different approaches to this single decision. Western mechanics grab whatever the computer screen tells them and move on to the next car in the service bay. My name is Kenzo, and after 18 years working inside Japanese service facilities, I can tell you that this one variable explains more about engine longevity differences between Japanese domestic market vehicles and Western market vehicles than any other single factor I have encountered. The decision is oil viscosity. The number I'm referring to is the weight rating printed on every bottle of motor oil, the designation like 0W20, 5W30, or 10W40 that most owners assume is standardized and universal. It is not. That number is a starting point, a factory recommendation based on a new engine operating under assumed average conditions. Japanese mechanics treat it as the beginning of a conversation, not the end of one. They understand that oil viscosity selection is the single most important ongoing decision affecting your engine's internal wear rate, and that optimizing this decision as your engine ages is the difference between catastrophic failure and indefinite operation. Let me explain what these numbers actually mean, because understanding the mechanics is essential to understanding why this matters. The first number, followed by the W, indicates cold temperature viscosity, how easily the oil flows when your engine is cold and oil has drained away from critical surfaces overnight. Lower numbers mean thinner oil that flows faster to upper engine components during cold start, reducing the dry start wear that causes more than 70% of total engine wear over vehicle lifetime. The second number indicates hot operating viscosity, how thick the oil remains when your engine reaches full operating temperature and oil is under maximum thermal stress. Higher numbers mean thicker oil that maintains a more robust film between moving parts under heat and pressure. Modern manufacturer recommendations have shifted dramatically toward thinner oils over the past 2 decades. Engines that once specified 5W30 now call for 0W20. Engines that once used 10W40 now specify 5W30. This shift is not primarily about engine protection. It is about fuel economy ratings. Thinner oils reduce internal friction, which reduces fuel consumption, which helps manufacturers meet increasingly strict emissions and efficiency standards. The engineering calculation accepts slightly increased wear rates in exchange for improved fuel economy numbers that affect corporate compliance targets and marketing claims. This trade-off makes sense for manufacturers who benefit when engines fail after warranty expiration. It makes considerably less sense for owners who want their engines to last as long as mechanically possible. Japanese domestic market service facilities approach viscosity selection completely differently. They recognize that factory recommendations assume a new engine with tight clearances operating under moderate conditions. As engines accumulate mileage, internal clearances increase due to normal wear. Bearing surfaces develop microscopic imperfections. Piston rings wear against cylinder walls. Camshaft lobes and lifters develop wear patterns. These clearance increases are normal and do not indicate failure, but they change the optimal viscosity for that engine. An oil weight that provided perfect protection at 20,000 miles may provide inadequate film strength at 100,000 miles because the larger clearances require thicker oil to maintain proper separation between moving parts. Japanese mechanics adjust viscosity recommendations upward as engines age. A vehicle that left the factory specifying 0W20 might be transitioned to 5W20 at 80,000 kilometers, then to 5W30 at 150,000 kilometers, then to 10W30 at 250,000 kilometers. These transitions are not arbitrary. They are calculated based on compression test results, oil consumption rates, and observed operating temperatures. The goal is maintaining optimal oil film thickness throughout the engine's lifespan, rather than adhering to a factory specification that assumed conditions no longer exist. Here is the specific protocol used in Japanese taxi fleet maintenance, applied to vehicles that routinely exceed 500,000 kilometers on original engines. New vehicles receive factory-specified viscosity for the first 50,000 kilometers. This period allows engine components to complete their break-in wear patterns with the oil weight engineers designed around. At 50,000 kilometers, technicians perform a compression test and oil analysis. If compression remains within 95% of factory specification and oil analysis shows normal wear metal levels, factory viscosity continues. If compression has dropped more than 5% or wear metals exceed baseline thresholds, viscosity is increased by 1 grade. This evaluation repeats at every 50,000 kilometer interval throughout the vehicle's service life. The results of this protocol are documented across millions of fleet kilometers. Engines following viscosity progression schedules show 40% less bearing wear than identical engines maintained on factory-specified oil throughout their lifespan. Oil consumption rates remain stable rather than increasing progressively with mileage. Compression readings decline more slowly, indicating reduced piston ring and cylinder wall wear. The engines reach 2, 3, even 4 times the mileage that Western owners consider normal lifespan, not because of superior Japanese manufacturing, but because of superior Japanese maintenance philosophy. Now here is how to apply this knowledge to your own vehicle. The first step is understanding your current situation. Check your owner's manual for the factory viscosity recommendation. This is your baseline. If your vehicle has less than 50,000 miles and you have no symptoms of increased oil consumption or decreased performance, continue with factory specification. The engineers calculated this weight for your engine when new, and it remains appropriate during the early portion of engine life. If your vehicle has between 50 and 100,000 miles, consider increasing viscosity by the minimum available increment. If your factory specification is 0W20, transition to 5W20 or 0W30 depending on availability. If factory specification is 5W30, consider 5W40 or 10W30. This modest increase provides additional film strength to compensate for normal clearance increases while maintaining adequate cold start flow characteristics. If your vehicle has between 100 and 200,000 miles, a more significant viscosity increase may be appropriate. Engines in this mileage range have accumulated measurable wear regardless of maintenance history. The clearances between bearings and journals, between piston rings and cylinder walls, between camshafts and followers have all increased. Thicker oil fills these larger gaps more effectively. Consider increasing viscosity by 2 grades from factory specification. A factory 0W20 engine might run optimally on 5W30 at this mileage. A factory 5W30 engine might benefit from 10W40. Beyond 200,000 miles, oil selection becomes increasingly critical. Engines at this mileage require careful attention to both cold start protection and hot operating film strength. Many Japanese fleet operators at this mileage range use seasonal viscosity switching. During cold months, they use a lower first number for cold start protection, perhaps 5W40. During warm months, they switch to a higher first number for improved hot stability, perhaps 10W40 or even 15W40 in hot climates. This seasonal adjustment optimizes protection across the full range of operating conditions the engine encounters. There is one critical exception to this viscosity progression guidance. Engines equipped with variable valve timing systems, particularly those using oil pressure to actuate timing adjustments, are sensitive to viscosity increases. The hydraulic actuators in these systems are calibrated for specific oil flow rates. Significantly thicker oil may cause delayed timing response, rough idle, or check engine lights related to timing system performance. If your engine has variable valve timing, limit viscosity increases to 1 grade above factory specification, unless you experience oil consumption or compression loss that indicates larger clearances requiring heavier oil. Monitor for timing-related symptoms after any viscosity change and return to lighter oil if symptoms develop. The cost of implementing Japanese viscosity management is essentially zero beyond what you already spend on oil changes. You are simply selecting a different weight, rather than automatically choosing factory specification. The benefit over vehicle lifetime is measured in tens of thousands of dollars of avoided repairs and years of extended service life. This is not a product to purchase. It is not a service to schedule. It is knowledge to apply every time you change your oil for the rest of your ownership of any vehicle. Japanese fleet operators did not discover secret manufacturing techniques or proprietary additives. They discovered that engine longevity is primarily determined by maintaining appropriate oil film thickness throughout the engine's evolving internal geometry. Factory specifications assume new engine clearances. Real engines develop increased clearances with use. Adjusting viscosity to compensate for this reality is the single most impactful maintenance decision you can make. It costs nothing extra. It requires no special tools or skills. It simply requires understanding that your engine at 100,000 miles is not the same engine that left the factory, and that optimal maintenance must evolve along with the machine being maintained. Your factory manual was written before your engine turned its first revolution. It could not know what clearances would develop. It could not predict your driving conditions, your climate, your maintenance history. It provided a starting point appropriate for a new engine under average assumptions. You now have information that allows you to move beyond that starting point. You now understand why Japanese engines routinely reach 500,000 miles, while Western owners accept 150,000 as normal lifespan. The engines are identical. The manufacturing is identical. The difference is a single decision made at every oil change, a decision that compounds over years and miles into the difference between premature failure and indefinite operation. If this changed how you think about oil selection, subscribe to Secret Japanese Garage right now. Hit the like button because it tells the algorithm this information deserves to reach more owners who are still running factory viscosity in engines that evolved beyond those specifications 100,000 miles ago. Drop a comment telling me your vehicle, your current mileage, and what viscosity you have been running. I read every comment and I want to help you find the optimal weight for your specific engine at its current stage of life. The knowledge that keeps Japanese engines running forever belongs in your garage. I will see you in the next one.